Hello, hello, hello. Okay, now it seems to work. Yeah, thanks for telling me. I was looking at the thing and it didn't move, and I actually I woke up from a nap. That's why I'm streaming later than usual today. So I'm a little bit out of it right now. Hey Phil. Welcome, welcome. Right. So we had an issue with basically updating an animation was really cumbersome for the CPU, I guess. Still feel like it shouldn't be that much of an issue, but I also double checked the models, and it did say it was like low poly models in the thing. So okay, I'm also gonna fix the starting camera. So this should be like negative. Negative, and then I want to start at the max here. Max 40. So I'm gonna start at... No, wait, that's max. The other way around. Min. Okay. And now I just want to change the original... Wait, I still feel like I'm too... No, I just need to change direction, I think. And target is self at dir. So we're looking down at an angle. But I want to look... What if we do that? Wait. Yeah. What if we do this? Okay, that's better. And then that. There we go. That was kind of what I was thinking. So we can see the thing directly here. Okay. I still don't really like how it looks like when you're zoomed out. I'd rather have the top, like more top-down view, that you're just moving up. Maybe not changing the fold at all. You're just moving the camera up or down or something like that. But anyway. Cool. also move us up a little bit more. Okay, so how do we fix this issue with the thing? This here. Like, do we really have to use GPU skinning? It feels like... I'm gonna check what's going on in here. Because it says it's like low poly, you know. If it needs to update a bunch of vertices, you know, you can think of it needs to loop through every vertice and do some transformation on it. So if it's a high poly model, there could be potentially a lot of things it needs to do. But you can see here that, you know, you can kind of see, you know, at first glance, it kind of looks sort of not low poly, but then you kind of go and look at the edges, and yeah, you can see it's very well done here. I mean, to my eyes, I'm not an expert, but there shouldn't be that many vertices, I feel like, but okay. I mean, I guess it's better to have GPU skinning than not. Hello, Igetux live cam. Yes, I started having it peer pressure. That's what it's called, due to peer pressure. Now I'm just trying it out and seeing how it works. All right, so let's go and look at. Is it shaders that will have the thing? Or was it something else? Models. Sometime I'm gonna go through and look at all of these. Particles blending. That could be pretty cool. Models. Yeah, I think it was in here somewhere, maybe. Here we go. GPU skinning. Okay. So apparently you can use a shader for this. It must be a valid shader following raylib attributes uniform conventions for GPU skinning. Okay. So I guess this function will like detect that somehow. I'm gonna double check the source code just to be sure. Good and flashy. Okay. Hello, Blue. What's up? What's up? Thank you. Nice to see your text. Alright, so we have update model animation, I believe it was. Yep. Alright. Update model animation bounds transform matrices for a given frame. Request strength could be fractional using a lerp interpolation between two frames. That's pretty cool. Update vertex animation data is uploaded to GPU in case of CPUs. Wait, updated vertex animation data is uploaded to GPU in case of CPU scanning. Okay, for GPU scanning, bone matrices are uploaded to shader on draw model X. So how do you know which one to use here? CPU scanning. Update CPU buffers uploads on GPU scanning not supported. Use CPU. Like, I don't get it. It doesn't, like, there's no, like... Update model required for CPU to upload and animate the vertex. Like, it seems like this is always called. I don't really understand. And this doesn't even use draw model X. It's required to be enabled at raylib compile time. Maybe there's different versions then? What's happening here? I was just lowered IQ. Okay. Okay, so we basically have to set this to true. First of all, I guess. Oh, it has like a shader on the thing. This will... So skinning shader could be required to be assigned to all material shaders, just to make sure required uniforms are being updated for the mesh using that. Just to make sure required uniforms are being updated for the mesh using that material and shader. So are they automatically doing that by doing this? Because I didn't see them update anything here. Unless it's happening in here. Or maybe here. I don't know. It's kind of unclear how to do this, I feel like. But okay, let's just... I guess we'll follow the example. Even though some examples are like wrong. But there's no compilation errors in this one, I don't think, no. So, okay, so this one is like skinning, yeah. 2 shaders, skinning something something. So we got examples, models, resources, shaders, this one, and we got skinning. Why are there so few? Oh, because we're in models, right? So let's grab these. This is the vertex one. All right. And now we have the fragments shader. Cool. All right. I'll remove the version number because that's being done outside. Now, do we need to kind of change anything here depending on the model? I don't know. This one seems pretty straightforward. Why do we even need this? I guess to get these. But we probably want... Like, what happens if you have multiple shaders? One active shader per material slot. Because we also have the lighting shader. Which also is this. I mean, we might have to merge them then in that case. Okay, well, anyway. Also, why is it set on shader 1 or material 1? Is that like it doesn't have to be on 1? I guess we'll follow just assigning to materials 1 for this model. Okay, but why? Okay. I guess we'll do the same. So I'm gonna go to assets. Well, let's go to, where do we create these? I think tower defense system. Spawn enemy. And we'll grab the renderable. No, 3D. Oh yeah. I'm gonna get the model. And then we're gonna do materials 1 shader. Also, how do we know that it has that material? It seems like it just yeah. I don't know. It just loads the model. There's no like allocating more materials on it unless it always allocates more materials. I don't know. I mean, we can't check like material count. What if we only have 1? Okay, let's just do it how they do it. Okay, so shader, this is gonna be get shader, and this will be skinning. I guess if we don't have it, we return. Okay, and now we need to actually add this shader here. Okay. So now the enemies should have the skinning shader. But, I mean, we still do the same work, so I'm not convinced this will do anything. It's gonna start lagging at like 5 models. Yeah. Wait, is it lagging or is it not lagging? I'm pretty sure it felt like everything slowed down. Yeah, definitely. Yeah, so it's still like, basically nothing happens. Let's double check what they're doing here, if there's anything I'm missing here. So, that's loaded in. We set the shader to the skinning shader. We have some animations. We still call update. I guess you have to do this. How would you otherwise know what animation to play and all that stuff? And it mentioned something about draw model X. So I'm gonna go over to renderable 3D model. So we are using draw model X. Okay. For GPU skinning, bone matrices are uploaded to shader on draw model X. And the difference between that one and this one is that this one you can specify another animation and it will kind of, I guess, blend the animations. So you can have a smooth transition into another animation, which is pretty cool. Fallback in case GPU skin is not supported or enabled. But where do you have the logic to fall back? I don't understand. Hello XRA. On the skinning shader question, you'd want to merge it with your lighting shader code, and you can use if dev to check if skin is defined or not. Basically, you have to compile two variants of the shader, then you can use the skin version with lighting for skin stuff and other like regular meshes. Raylib doesn't give any stuff for managing that variant shader, pre-process stuff out of the box now. Okay, thank you for that answer to the question there. Yeah, that seems to be because you can only have one shader, so I guess you would have to do that. Oh yeah, okay, hang on. I forgot something. I forgot to actually enable GPU skinning. So I have to I'm always unsure of exactly where this goes though. Like, apply to all C source codes files owned by this model. What does that mean? What is it? Like, okay, well, anyway. I mean, I guess we could test it. We could test maybe somehow. Not sure. Maybe they will. Maybe it's logged by Raylib or something. I don't know. No, it's still. Yeah. Almost feels worse than before. Oh, okay, now things are happening. Expected value in expression. What? Isn't it enough that it is should be defined? Or do we have to say 1 here? Oh, I see, they're not using if def. They're just using if. So maybe that means it has to be true. Like the value true. Maybe. I'm just guessing here. Okay, this is promising. Okay, somehow this magically works now. Great. I was actually skeptical that this would even do anything because yeah, I don't know. It just felt like nothing changed, but okay. Maybe different versions are used, like the function. I don't know. I have no idea. Okay, but it works. Hey, cool. Awesome. All right. Fix that issue. So, I mean, what we could do, perhaps... Yeah, because, you know, I've been thinking of generating shaders anyway. So you could probably just generate a shader based on what you need for a specific thing. So, yeah, that would probably be what we would end up doing here. Because this also has a vertex shader. The only thing this is doing though is like calculating some stuff and then pushing that on. I don't really understand why this needs to happen here. Why couldn't this happen in the fragment shader? Like, if we have the source, you know, if we have these things, we should be able to calculate this in the fragment shader, right? Okay, well, anyway. Yeah, and then we have all this crap here. Skinning, and the skinning fragment shader. I mean, we could just remove this one and replace it with the lighting. This doesn't even do anything. It just takes into account, like, this is, I mean, this is just doing whatever, I guess, the standard default shader is doing. I don't even know why they have this. So the only thing we really need is this part, calculating these things. And I guess we could just add this to the end of the skinning one or something like that. That stuff needs to be in the vertex shader, like frag position is transforming the vertex from old clip space, but often there's stuff that can be moved from vertex to fragment, like lighting calculation could be per vertex or per pixel, depending if it's a vertex or fragment. Okay. Cool. Oh yeah, I mean, I think, because in my mind, I thought that they were like, this is called first, and then the output is passed to the fragment shader per, well, the fragment, I guess the vertex shader is called per vertex. I guess. And then this is called like per pixel or something like that. I don't know. Anyway. Yeah, so I guess it makes sense. I actually don't know. I don't know. I don't know what I'm talking about. disregard my... It's just guessing. I'm just guessing these things. But okay. So cool. Should we try and just merge them right now? I mean, I could, the lighting one, we could just replace, but the problem then is we don't have these inputs. Alright, I guess these could potentially have stuff set, even though we don't set them here. I don't know. Okay, well, if we go to skinning, no. So text chord is just that. Color, normal. This is the same thing though. Except the normal is a different type here. No, it's not. What? Vec3. Oh, skin normal is different. Okay. Okay, I guess we actually do this then. Skin normal, yeah. And then, what about this though? This should be skin position actually then. But skin position is a Vec4, so we should just use Vec. Okay. Why are these Vec4s? Okay, well anyway. We're not working with 4D. Alright, so lighting FS. I think now we can just do this assets and just replace this with lighting, and that should work now. Hopefully. No? Okay. Something went wrong. Oh, I know. Because the lights are only added to the other shader. Right. Create light. Shader location. Yeah, so this is only on... God damn it. I guess, we could have like a, I guess we could have like a list of keys. Problem is this is a global, so I can't just call this multiple times. Let's just give a list of keys. And we'll create one for each key. keys. Now, why are you added here? Does that matter? It matters there. Set shader value. I mean, we could just move this out. And then just add one here. And the light, is that even used? Kinda. Yeah, I mean, yeah, it becomes an entity. Ah. It's not actually used. I don't think we even need this as entities. We can just call create light as is. And that should work. It's just that if we want to move them or something like that dynamically or something. Like, can shaders share these things? Yeah, and then you don't lose anything. Because really, the only thing we're doing here is we're basically creating this light. We are basically just setting these values on the shader as we're creating the light. And then we're done. And now we need a list here instead. I really hate that. Okay, let's see now. Okay, they are very green. I guess that is correct because we have a bunch of green lights. Okay, but okay, so let's do this. Instead of setting the shader 1, let's just use shader 0, because that's where we have the texture as well, I think. Maybe? There we go. Looks, but I mean, they still should be kind of green, I think, because there's like a green light. I don't know. Maybe we should just remove, what if we remove the lights? No. Yeah, now everything should just be the ambient lighting. There's basically no difference. Okay, whatever. There's something weird going on with the lighting stuff. Light dot starts at 0, so if that is like that, this whole thing should become 0. And then we add the ambient, so it should be very dark, but it's like full brightness. Okay, I'll check that out at some point. Let's go ahead and continue with like logic stuff, because I want to get to kind of having these towers attack these things and have them die. So let's kill some barbarians. Also, what's kind of strange here is their animation. Wait, I just noticed they are not animating. What the hell? Was I like hallucinating or something before? Is it because I changed it from 0 to 1? Now they're animating. I just kind of double check that it's not lagging here. I'm pretty sure we tested this before. Yeah, there's no lag now. So this is magic here. This is like a magic thing. Okay. Well, how does that work with the texture though? There's a texture here. I mean, yeah, the texture did work, but then... Or did it work? I think it did work first. Yeah. But when we added the lighting stuff, it stopped working. And if we add the... Okay, so if we add the things back... This is super confusing to me. Are they gonna get green? Okay, now they're green. Which could make sense. Let's just make these white. It also somehow feels like the texture is not correct. Oh my god, why is that happening? It's like I scroll in and try to do that. Okay, it's the first time. Okay, reproducible. Okay, so if I haven't, I guess, rotated maybe? No, now it's doing it every time. Is it zooming? Okay, so now I can't rotate anymore, apparently. But they are not entirely white. There's some weird spots where they are not white. So maybe it's just like the intensity of the lights or something. All right. Yeah, but these lights don't have intensity. So let's go here, and we have like the light thing. There's something called like graphics light attenuation. Light intensity decreases for further from the source. Yeah. So it starts out, I guess, 100%, then falls off. Proportional to 1 distance squared. So inverse square. So we have like normalize. This is like the distance normalized. Okay, that's just to get like against the normal, right? So there actually is no distance calculation here. There's no attenuation calculation here. So we take like the distance here, we calculate the actual length of that, attenuation. Okay, and then we just times that by everything. Really? Even the ambient? That seems wrong. No, that's wrong. Right? Ambient is like a global thing. Let's do light. I mean, let's not normalize this. Whatever. target. And I'm just gonna do it here instead. Okay, so now we have like a basic attenuation. Yeah, that seems wrong to me also. Yeah. Per light. Oh, sorry, you didn't actually see anything when I was doing it. So I put this in here. Oh. Yeah. Here, yes. I put this in here. So I basically calculate the distance, and then I'm copied their calculation for the attenuation, which is clamping this value 10 over d. I guess this is like what you could modify then to change the curve there somehow, perhaps, maybe. I wonder why they do 10 over... Where's the square actually in this? Okay, well anyway, that's one way, I guess. And then it clamps to 0, 1, which seems fine. And then I just times that by... This is gonna be kind of the final light value here. The color like factor there. I think. Yeah, because that's just times over there. So actually this is added between each light. Yeah, I guess. And then now it looks a little bit better, I think. Yeah. I mean, the actual lighting position and stuff, you know, it might not make sense that there are 4 lights randomly placed here, like you have 4 suns in the world at ground level, but you know, whatever. I just want to see that the shader works here. Cool. And these ones don't have the lighting affecting them at all. So I wonder why that is. And also the ground does not have it at all either. So what's up with that, man? Oh, probably because we don't actually set the shader here. Now, will this actually work? Yes. Great. We can now kind of see where the lights are. Cool. And now the last is these towers here. They are... Where is this happening? Controllable. Left click. No. Where is that happening? Here. Create prop. I'm pretty sure we always set the shader here. Or when we load it. Maybe I removed it. Shaders get shader lighting. Yeah, so I don't basically everything starts out with this shader, so I don't know why that's happening. But I guess let's do this anyway. Yeah, I don't know why that's not working. It's not working now either. Material map. Let's just set it on 1 as well. No. That is strange. material count. Let's check this. Oh, right, I need to actually click. Click, click, click. Wait, what? Huh? Oh, right, this is the wrong goddamn thing. Oh yeah, it's the tower defense. Here. Update interface. Left click. We're actually creating it right here. And we're even doing stuff to it. Okay. Model is gonna be this. Okay, let's just try this. No. Let's try to set it on 1. Okay, there we go. Now it works, I think. Even though it kind of looks a bit strange, like why is this so bright? I guess it's because of the direction or something. Okay, well, anyway. Cool, it works. We have some super cool lighting effects. Yep. I mean, what we could do, the thing I changed here, creating a light, and then we have this light thing. What we could do is, well, we actually have this as a constant. We could just have a global for the lights here. This is a thing like this. And then we can get the shader out by saying lights 0, 0 to lights count. And here we can do lights light count equals to light. Okay. So now we have them available for us to do stuff with. Now, what we could do is we could say this is so stupid. I just want to test it. I just want to test this just to see the dynamicness of the lighting of the lights. So we have a position. I want them to rotate around the origin essentially. So I'm just gonna go to update and do this here. just because, whatever. Update lights. All right. Let's import light, get lights. We can loop through that. And we get a light. And actually, I think these need to be mutable, perhaps. And now we can change the position based on the thing. We could just rotate them. Like every frame. So, rotate. The problem is this only works for vector 2, yeah. And you work for vector 3. Right, so we want to rotate by axis angle. And the axis is going to be, I think it's the y-axis. And this, let's just pick some small number per frame. And there's 60 frames. So 60 frames, so 1/60. So this would be 1 revolution per second, I think. And then update values. Oh yeah, I forgot. Actually, this needs to be like times however many shaders we're actually planning to use. Number of shaders is 2. So this would be times number of shaders. And this would be times number of shaders. And also we kind of need the actual shader because we're passing it in here. I mean, we could just, I get one thing, we could store it here maybe. We could store the key instead, I guess. Shader key. Yeah. We store the key. And so the shader is gonna be, and here we actually gain. Oops. Get shader. Like that key. Okay, there we go. So we can update the values. That will change the uniforms for the shader. Okay. And also we actually need to assign the position here. Fingers crossed. Let's see if we got some rotating lights. Now? Why? Maybe the calculation is wrong. Let's... I guess, what if we just change X by 1 pixel per frame? Will they move? Like now they should just like disappear. Wait. Okay. So the characters... Yeah, it works for the characters. But not for anything else. Because they're using a different shader. But it should happen for all shaders. So somehow it's not doing that. So each light is mapped to the key. The locations are mapped to that key as well. Everything is mapped to that. And next one should also be so. And we get the thing. And we update the values. And this happens for every light. Hello, Inparn, what's up, what's up? Welcome back. No, let's only do it for like the first light, maybe. You made breakfast, nice. Yeah, you can see the light going around. What if we only create one light? Like, I know this won't fix the issue. I'm just trying to look at so we can more easily see the thing. The characters are definitely affected. You can see that the light is moving around. So it's affecting the skinning shader, but not the lighting shader. Question is, can we use this? What if this is 0? I mean, yeah, okay. So we could just use skinning for everything then. Let's just have one shader, I guess. That still feels wrong, because it's like, it should work, I think. Okay, there we go. We have a dynamic light. Disco TD here. Maybe this will be, you know, if you had this as a red light, it would be kind of like an alarm going on around. Like, the boss is coming. How's the game going? It's going, you know, forwards. I'm dealing with a bunch of stuff. Like, the purpose of this project is for me to learn kind of the basics of like 3D stuff. So you know, we have a shader, we have lighting shader. I also have now these animations, even though it looks kind of weird now, but they are playing some kind of animation here, using GPU skinning as well. Although, you know, I can basically copied over some shader, you know. I basically copied some shaders and fiddle around until it works. And yeah. But the rest of this game is essentially, you know, it's just a 2D plane. There's no like 3D stuff. There's no like collisions or anything like that. I am using, however, Box 3D. So, also, why are these still falling down? Oh yeah, because I didn't change gravity for the other thing. We should still have like the ambient light, but the ambient light is so low, I guess. Yeah. Red. Does it kind of look weird? Like, should it be more red here? Or is it just like an optical illusion? I don't know. How's it going for you, Inpon? But let's just have one light in the sky, I guess. And let's not do this weird thing. Okay. I mean, I would rather have like, you know, like a global directional light. Is that what this is? Because this doesn't take the position of the thing into account. So there is basically no attenuation going on there. I guess we could try it. Directional and target. Target is like origin. Yeah, and then we change position. So so now it's just straight up. So if you put this like over here somewhere, it's gonna be, you know, 0.75, 0.25 or something like that. This would be kind of be 45 degrees, I guess. And this is like 20 something degrees or something. No. 70 something, anyway. Okay, let's see how that looks. It's going pretty good, just going kind of slow, because if I do too much, I'll get burned out easily. Alright, I see. Yeah, you better be careful about that stuff. It's tricky. Sometimes maybe you feel like you wanna do something maybe and you can't. But yeah, just hang in there. Okay, and then the shader. Now I wanna. I guess I only wanna do this if we actually have directional light. So I'm gonna. Yo, attenuation here is just 1. And then we only do this if we have a point light. There we go, I guess. And we can still see some shadows and stuff happening, I think. Well, not shadows, but like, you know, lighting difference. Okay. Cool. Yeah, you can see that the light comes from basically where I am, basically, right now. Alright, cool. Well, just want to stop by and see how the game's going. Good luck. Maybe back tomorrow. Alright, thanks. See you tomorrow, maybe. Take care. Alright. Cool. Okay, so let's get to enough about the lighting stuff. Let's get to actually having these towers shoot and kill these guys. So the towers. So what I'm thinking is, you know, from like Warcraft 3 or whatever, these kind of TD games, if you have a single target tower, it has like, it acquires some kind of target that is in range. Now that's the target and it shoots on it, you know, when it has the cooldown. And if something falls out of range, it needs to acquire a new target. So that feels to me like some kind of state machine thing. Which that we can do. And then we need to spawn like a projectile that shoots the thing. I mean, I guess for now we can just have them have fire instantly to kill instantly or something like that. Although we don't really, we can't really see that unless we add health right now to those guys. We don't have... Okay, so let's do a couple things. Let's go to tower defense, spawn enemy. Now, how do we differentiate that you are actually an enemy? I think it's because you have a checkpoint. But let's create like enemy, create component enemy. Oh, I think I know why it has the wrong name and all that. Is because when I say create component, I actually assume that we're dealing with that I should have kebab casing. So when I do Pascal case, that it doesn't work. Okay, well anyway. Yeah, so the enemy has like health. I'm gonna make it a float. Or F32. And let's also have max health. I'm gonna make this kind of like a generic kind of game object type thing. Because there's really, well, I guess if we want to add a bunch of attributes to enemies, we could like have them as components. But every enemy should have like health, and nothing else really makes sense to have like health unless we introduce things like, you know, having units attack the enemies that are not enemies. That should also have health or something like that. I don't know. Good luck, man. Thank you, Piano. What's up? But let's do that. Let's have like max health. All right, we can add other stuff here later, but let's start there. And so then when we spawn the enemy, we also want to add an enemy init. Let's do like 3. It depends on what enemy we add, but let's do that. Okay. So now they have health. We should also then have like update enemies. Which is kind of this. This is kind of update enemies here. But this more updates the positions of them. Update spawns. I mean, this is update enemies. That's what it is. Yeah. So we'll grab enemy here as well. All right, and let's grab out enemy, and we can do that later. First, I want to check if enemy health is less than or 0, then the enemy is dead. I'm just gonna remove it for now. No, destroy and continue. Okay, so now they can die, essentially. Now update enemies. We should also have like update towers as well. So this would be a tower, or maybe we don't actually have that. Where was that happening? Over here. Ah, we're spawning the tower, right. We're adding a renderable. We are... What else are we doing here? Not really anything. Okay, so let's create... I mean, we could just create a tower component, I guess. That is like a tag. For towers. Okay, and then you are tower. Oops, would be great. All right. Now, so, yeah, I guess a common thing for the towers are that they should have like an acquired target, which is an optional context that we set to null. I'm thinking, like, if you're thinking about Warcraft 3, in Warcraft 3, each tower can have like multiple attacks, meaning it has like different kinds of attacks depending on the type of target. But I'm just like, if it's flying, for example, you can have one attack for flying enemies and one attack for ground enemies. I'm just gonna have one attack. Yeah, we don't need to make it super complex here. I just wanna do range. Let's have range, and let's say, I don't know, range is 10 or something to start with. We can have things like so usually, like in Warcraft 3, they also have like base damage and then like some dice added. I'm just gonna do min damage is, let's do like 1, and max is also 1 for now. Okay. So basically I'm thinking like all towers have these attributes essentially, and if there's like, if you have like a poison, let's say poison tower, then I'll probably just add a component for that, like poison damage component or something. that will handle that. So not everything will be on here, but this is like generic for all towers. And then of course we have cooldown, which is going to be I don't know, 1 second or something, or 2 seconds perhaps. 1.5. Let's do 1.5. So we got range, min damage, max damage, cooldown. Okay, let's start there. So here I'm thinking first, let's get the tower. And the body. Oops. So I'm thinking here, first we're gonna check if we have an acquired target. And now we want to check if the target is still like within range. I guess we could also get the position here. Position target, and then we also want tower range as well. If it is in range, then we can go ahead with the attack. If it's not in range, we need to acquire a new target, so then this will become null. Yeah. Here we're actually just attack target. And then I guess we'll continue. I'm not really thinking about the layout of the, you know, ifs and else here. I'm just... So if we're down here, that means we didn't have an acquired target, or we lost the acquired target. So we have to actually acquire a new target. So the tower... so I guess like if acquire new target, position and tower, and then let's say we get this target out. If we have a target, we need to attack the target here, and then we're done. This could also be like encapsulated in if can attack acquired target. And we have like tower position. Yeah, that's basically it. Then we get the target out and we attack the target and then continue. So that's basically what's happening here. Tower position is a world vector. And here we get an entity. Return the target. I mean, we could just merge these into like get acquired target or get target. You know, get target, tower position. We get the target. If we have a target, we attack the target, and that's it. Hello, that guy Doru. Rare code cam. Yeah. Welcome, welcome. Position. All right. And this could be actually condensed into return, can attack the acquired target, tower position, or else acquire new target. Let's do same thing there. There we go. And then over here we'll return null. Okay. Acquire new target. So I'm just gonna do a brute force here. So we'll get then we need game as well. And we're gonna get enemies. And we're just gonna check if enemy position is body position, if they are in the thing. Hello, not Slider. Rare face cam stream. Yeah. It's a new thing. A new era. Oh man. Yeah. You know what? I'm just gonna go and grab some water. So I'm gonna also show you this. Loomer's a real streamer now. Yeah. Yeah. I basically just recorded that. So I have like I just made a
a web page with a video in the background and just a text on top. Because I was looking at some, like, I noticed there were some online templates that you could use for, like, be right back and stuff like that. But it was just so cumbersome to get into that. So I just made my own very, very, very simple web page for that. The Zig Metroidvania, yes. I do plan to continue on it. I just I like kind of taking a break from it a little bit, coming back to it, doing some other projects in between and stuff like that, just so I don't get like burned out on doing the same thing day in and day out. I really enjoy like variety, so there you go. All right, let's continue. Acquire new target. So we want to just check if, so we just want to get the distance. Distance from enemy position to position, and if the distance is less than or equal to tower range, then tower acquired target equals to context, and we return with the context. If we go through everything and don't find anything, we return null. Cool. All right. Okay, so we need to define is in range, which we kind of just did here. So, whoops, I'll just take this part and like is in range. And we need what do you pass? Position of the tower, the target. So position is a vector, target is context, and then the range. Yeah. So we need to grab the body from the target. We have the target position. Calculate the distance. If that is less than the range, we will return true. Actually, we can just return this. All right. So then over here, we can simply say if is in range, position, context, tower range, we will set you to context and return context. All right. Okay, so the only thing left is the actual attack. So here we need to check if tower oh yeah, we also need like next attack at, that's the like the timestamp of when the tower actually can attack. So if that is less than elapsed time, then we can attack. So then we also have to say increase this by the cooldown, and we attack the enemy. So the target, let's get the enemy from here. And oh yeah, we actually have like min damage, max damage. So we have to do like random float, or is there, does it have to be an int range? Okay, well, there is. I'm just gonna add this convenience then. Float range, random float range. It's gonna be a float f32. We're gonna have min and max, and we're gonna return random float f32, and then we times that by max minus min plus min. Pretty sure that's how you do it. So if you have like min 1, max 3, then this goes from 0 to 1 times 2. So 0 to 2, and then plus 1, so 1 to 3. Yeah. All right. And now we can say random float range, and min is tower min, and max is tower max. Okay. And the way we would see this happen, we don't see or hear anything. So we simply have to check that the enemies will actually just die, or they're just gonna disappear. What is this now? 188. Expected 3 arguments. Oh yeah, you need game as well. Okay, no. Tower defense 225. Oh. So we return null if we don't find anything. This was quite a new target, right? Expected vector 3 found. Oh, so I never actually used this here. I guess distance u is type of v. Right. This also needs to be converted, of course. All right. And there we go. We killed one and we crashed. All right, let's see what's happened. Oh yeah, I mean I know what happened. So when we try to get, so the target dies, we still have it as an acquired target. So next frame is not going to be valid anymore. So when we try to get stuff from that entity, it's going to crash. So we have to check if the entity is actually valid first. So when we try to get a target and we try to look at our acquired target, we first have to check if the target is valid. If the target is valid, then we can check if it's in range. No, sorry. Wait. If the target is not valid or that it's not in range, there we go. Then we're doing that. Okay. Boom. Wait, why are you slowed down? Oh, because they're like colliding or something? Okay, I win! Huh, okay. So the dynamic, well, first of all, the box 3D bodies are not removed. I just realized, because that's what was happening there. So we need to remove those when things die, essentially. So what we could do is, well, there is a way in this ECS system you can actually register an event listener for stuff like that. So you could do like ECS and then no wait, we don't need ECS, we need registry, we need like, what is this called, on destruct, return signal for given component, add remove listener. I mean, we could either do it here. I guess we could also... Now, I wonder if this works. You have a body. Then we will call... Wait. Registry... Huh? Oh. On destruct. Right. So connect with the function. Now I think the only thing we really need is the entity. So on body removed. And delegate params, sync from tuple. Wait. Registry. Okay, so a registry entity. So we get a registry and entity. And that's all we need. All right. Now we can get the body ID from here. So this would be like B3 body ID from entity, and then we can destroy that as well if it exists. So we should do a try get. If we don't find it, we return. All right. And just to make sure this gets called, I'm gonna log out here. Raylib is the only dependency for this. Raylib and ECS library. Okay, that seems to work. Yes, that works. Cool. Great. All right. Okay, well, that was one thing. The other thing is that I don't actually want these to be dynamic like that. I want the enemies to be basically collision free. They are not affected by gravity, and they are not supposed to actually collide with anything. So I'm gonna change this to kinematic, which I believe is that. And maybe now we don't actually need to create a hull or something. I don't know. No, now they're not moving at all. Okay. Okay, let's go to Box 3D and check this out here. Box 3D. Oh yeah, and Box 3D as well. Sorry, Box 3D, Raylib, and ECS. I'll actually just go into the zone file here. Yeah, essentially. And, well, I guess, you know, for compiling to web, that would also be actually interesting to see if this runs on web at all. I do have like a web target. I can actually just press a button here to run this on web. Session. Which one is that? It's F7. Okay. So F7. That will kind of compile it for web. I'm not sure how good this is gonna work because we have like a lot of resources that are not lazily loaded. So everything is like in the WASM file, I think. So that the file is gonna be huge. Okay, well, while that is going, I'm gonna check out the documentation here. If it, I'm pretty sure there was documentation somewhere. I think. Collision. All right. Blah, blah, blah. Collision. I'm only interested in like just having something that has the physics simulation without collision, essentially. Fact. Oh. I actually got build errors. Okay, well, I'll figure it out later. Foundation, was that something? Kinematic. Define attachment. How to drive a kinematic body to reach a target. Okay, so we have kinematic. It does have a hull as well. Why is it scoped like this? Right. So what are you doing here? Set target transform. So you're just moving it manually. Or what? Cast shape cast array. Weeble controls. I'm just trying to find some example of them. Okay, because dynamic. So static means it can't move, essentially. And dynamic means it can move and it also collides. And kinematic, like, I think maybe it was the box 2D that actually explained what that is. Yeah, it should be a physics object that does not like resolve collisions on its preset velocity. So you can't change it? It can push dynamic bodies out of its way. What?
Does not collide with static or other kinematic bodies. So it can, so dynamic bodies reacts to kinematic bodies. I mean, this is according to Google AI, but movement, setting linear rather than applying force. Okay, so you have to set them. I see. But I don't think there is such a function, though. That's the thing. But we definitely, I think kinematic is definitely what we want to go for. And then we'll go to body. Set. So we have apply impulse. Let's do set velocity. Okay, we can actually just set the velocity. I don't know why I thought that we couldn't. Also, let's use these convenience functions. No, this is from. Okay, and then I don't think we actually use damping then. We just set the position. Yeah, so update enemies. Or set velocity, I mean, instead of impulse. We want to set velocity. And yeah. Hello, Vivex, what's up, what's up? Okay, they're fast. Hey, speed works. All right, cool. Oh, I see. So when we create a tower, it, like you say, it instantly kill the thing. Is because when we set the next attack at, we just add plus equals, which means that because this starts out at 0, so if you're at like 100 seconds into the game, it's gonna actually fire. It's gonna like fast forward like 100 seconds. It's like attacking for 100 seconds in one instance, sort of. So let's just set this to like elapsed time
plus cooldown, and then that would fix that issue. So like now I'm waiting a little bit. And now they don't just instantly kill these guys. And in fact, they don't kill anything at all. What the hell? Okay. Like the enemies only have 3 health, so... Okay. So, cool. Now I want to add projectiles. So, and the way this kind of changes how this works, I guess, I mean, yeah. So instead of just immediately like reducing health of the enemy, we would spawn a projectile that would be launched against the enemy. It will land on the enemy and it will deal damage at the moment it lands on the enemy. So so we'll have to do that. Spawn projectile from let's do like position. Well, we need game position tower. Well, let's do like tower position to target. All right. And then I guess we could determine the damage already before, maybe, or maybe no. Probably have to do it later. I'm gonna add a projectile component, which will have a source context. So we know where it came from. Okay. And then let's add this spawn projectile. Actually, I wonder, is there actually like a function for, or a code action for, it would be cool if there was a code action for like implement function. But yeah. Position, world vector, target is void, and yeah, that's it. All right. I guess it also depends, like some towers maybe they do have like instant attacks, but Rust has that, yeah. Yeah, Zig doesn't have like a lot of utility. Like the LSP isn't even an official LSP. So, but it would be nice if they started to add those kind of nice things to have. I mean, I guess I could do... No, wait. Well, I mean, how hard would it be, actually? Because we have the information, like, of all the types here. I guess it would be kind of difficult because the types themselves... You probably won't get the type the way they are. Like this one, for example, I want this to be game.c.tower, but the actual type is just tower. So Zig, so we wouldn't know how to actually spell that out. It would be it would be difficult, I think.
and this one as well. This is like, well, this is the correct type, but actually I would like to use like the alias that I'm using. So that is kind of difficult, the alias and where they are located. Like I wouldn't want to auto import this because I already have game where it exists on game.entitycontext. So, well, yeah. Anyway, to implement it in the LSP should be too hard. Implement in the editor is harder. Yeah. LSP, the LSP has a lot of utility for that, but the editor does have utility as well. Like it can piggyback on the LSP for some things, but yeah, definitely harder, I think. Yeah, you're correct. But I think it would be hard just because of the things that I mentioned there to get the actual correct things that I actually want to have. Because in Zig, like the type aliases, how should it know which one to use? Like, yeah. All right, so spawn projectile. Well, we're just gonna have like one type of projectile right now, and we need to kind of find like a model for it. I don't know if we actually have anything right now. Is there like something like an arrow? There's narrow stairs. A sword. Let's check, because you know we have this stuff here. There are these props that I didn't actually. Oh yeah, so we could copy over those. K-Kit, Adventurers, and I guess assets. Yeah. Let's copy that to here. And let's run that. Okay, so now we have that. So now let's see, arrow. So now we have like arrow, bow, arrow, crossbow. I guess arrow bow is for the bow and crossbow for crossbow. So we can use like arrow underscore bow for the model. So let's create our entity here. Oh yeah. This is arrow bow gltf. Right? No? Yes, it is. Okay. The LSP was just joking there. All right. So we have this. Now it's like we have a little bit. It's like the ballistics. Maybe we need like an update function for the projectile.
position is just position, I guess. And then we also have 40. Okay. I mean, we could also just have it move onto the enemy. I think that Warcraft 3 actually does some kind of future projection, so it kind of it depending on the speed of. Okay. So that the arrow, when it's launched, it will already have its path set, and it always hits the target, unless the target changes direction during the arrow moving. So, for example, here, so let's say we have the tower here, and then we have the bad guy here. So this is the tower, and this shoots an arrow. The bad guy is moving in this direction. I'm hearing like scratches in the wall. And this shoots the arrow. Now the arrow kind of goes in an arc, is what I want. But the thing is, if we try to shoot where the thing is right now, we shoot here, the enemy would have moved down here. So we have to kind of predict where to shoot. So this is kind of difficult, because it's like the thing is moving down here. I don't know how much time it will take for the arrow to come over here. Or I do know how much time it will take for the arrow to come over here. So this, let's say this is like t, as in time, how much time it takes for that. But the thing is, if we then calculate that this, how much this moves in that time, and then we readjust to here, this has to kind of match t, because otherwise the enemy would have moved somewhere like else. You see the issue here? Like the enemy would have, like this t does not, so this is like t0, and but this is t1. Let it not be a calculus problem. It probably, I don't know. You can also just cheat and always target the enemy X seconds in the future and just change the speed of the projectile to match. Oh. Always target the enemy X seconds in the future. Change the speed. Like changing the speed like dynamically. I mean, you can probably calculate, because we have all the kind of positions and everything. Like, let's say we, like, first we can, okay. We change the speed of the projectile to match T1. Right, I see what you're saying. We can calculate like how much time it takes to actually reach the original target. If we're over here, it's gonna be a slower projectile, but it will, because it's closer, right? But it will land at the correct place. Yeah, okay. So the speed of t0, so the speed 0 is like, or sorry, velocity 0 will be, no, times 0 times the speed 0. So the thing here is t1. This is where it doesn't match up then. Okay, I don't know what I'm doing. Pick destination, match arrow speed for rise the right time, yeah. Yeah, we'll figure it out. I think I'm just confusing myself, but trying to algebra it there. Depending on how far in the future, pick enemy speed will determine average speed of projectiles, right? Yeah. From a straight path, you can likely figure some formula, but with corners, it gets way more complex. What do you mean corners? Do you mean if the enemy moves away? Like so this is all based if the enemy just has the correct, like if the enemy changes direction during the arrow moving, I'm not gonna have the arrow like be homing into the enemy, because we have basically it's gonna be very cumbersome to kind of calculate that stuff. I mean, technically we can, because the checkpoints are very simple. They are all static, and we could kind of calculate where they would like turn. But I'm just gonna say that, okay, well, if an enemy turns while the arrow is in the arrow is not gonna change anything, and I'm not gonna try to calculate that. It's just gonna calculate it as if the enemy moved, didn't turn, essentially. It's gonna miss, except that's the choice that we make. So does it miss, or will it like hit anyway? Because that's how in Warcraft 3, TDs in Warcraft 3, that's kind of how they work. It's like, even if the projectile kind of looks like it's missing the target, it hits anyway, unless it's like a splash attack, because then it's not like that. If it's a splash attack, it deals damage in an area around where it lands. While if it's not a splash attack, it will actually just always deal damage, even if it looks like it's missing. So we could, like, when the arrow kind of lands on the ground, it's just gonna deal damage. Or it hits 100% accurate for single damage projectiles. Yes. So I think I'm just gonna do that. Potentially, I will just check whenever the projectile hits the ground, it's just gonna deal damage to its target. So actually, that does remind me that we actually need a target here as well. Makes sense? Alright. Cool. Okay. So we got a path forward. So let's add... And the thing is...
So the source, well, the source is actually, we need the source. Tower context, and then we have the target. There we go. I don't think we actually need tower for this right now. Let's just remove that. Okay. So what? So now we need to kind of let's get the body, and we need to set velocity to be, actually the velocity is interesting because how do we want to do this? Do we, because I also want it to arc, you know, so the arrow is kind of angled. It's always going to be, I guess the arrow is always going to be angled in the direction it's going as well. So that would be easy to kind of rotate the model just based on the direction. The question is though, if we actually want it to have gravity now. So, well, we probably just want to add gravity to it. So, but then it's like, okay, how do we calculate? And now it's like a ballistics thing as well. Because if it's gonna go up a little bit, we have to calculate it goes up and then lands. I guess it wouldn't affect the speed, the 2D speed, like the XZ speed. It would only affect the Y speed. So I guess it actually doesn't matter how we angle it. Okay. Let's do like set gravity scale. All right. We're gonna set it to, I guess, 1. And velocity will be like calculate projectile velocity or something. And we need, I guess we need like position. Actually, now it's probably good to have actually the tower projectile speed. We could have that on there. Projectile speed. I don't know. Let's do 10 for now. So we got position speed, and then we need a target as well. Position, target position. Actually, we're just passing target because we need the speed and everything else as well. So position, speed target, and this would give us a vector. All right. So target position. Actually, we need target body. Target get body. Target position. Target's velocity. Was this the thing that we couldn't do? We couldn't get the velocity. Get linear. Yes, we can. Okay. 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 I might have remembered wrong. I don't know. It felt like I couldn't find those functions. But okay, maybe it was for acceleration. Like set acceleration. There's no set acceleration. I guess that would be used. That would be like apply force and that. Okay. But is there get acceleration now? Get acceleration? No. I guess that's not something you can get now, because it's like it changes over time, over the frame. It's like, okay, well, anyway. Yes, target position, target velocity. Okay, so okay, so now we have to calculate this here. So the speed, so I'm gonna get the relative. It will be basically position minus target position minus position. That is the relative towards the target. Okay. And then let's get the distance there. And the distance, so the speed is like distance per second. So time will be, so distance, so speed is distance over time. So to get time, if we multiply by time, we have time times speed equals distance, and then we divide by speed. So we get time equals distance over speed. Okay, now we have time. Time is precious. And now, so we have this time now, time 0. And now we can calculate how far will, like, where's the target when time 0 has passed. So that will be like target, so target future position is going to be target position plus
velocity times time. We could call this the future or something. Okay, so that is the future position of the target. So that is where we will try to end up with our projectile. Now we need to calculate what speed do we need to have in order to reach this target at the same time as the target. We would need to have, so we have the future position, brain is not moving forward. So we could, we could do this again. What do we get? We get like future relative. We get the future distance. Yeah, so now we have the distance to the future. And what we need is the speed to reach that. So we need the speed. So the future distance. This is now T1. Future 1. So we need to kind of have this be equal to future 0, which is distance over speed. So actually we need this to be equal to distance over speed, or just future. It's probably super simple, but my brain just can't go forward with this right now because it's like disconnected here. You have one length, you have a distance, a time, and the speed is just a combination of those. You shorten the distance, let's say, then you lengthen the time. So by the ratio that you're shorting, or the future, or the time it takes, let's say you double the time, you now have longer distance, right? So we take the ratio of the future and future 1, and then we get the future speed is going to be speed times the ratio. Maybe. I think it should work in some combination of this. Okay? And so the velocity will be so it's gonna be like relative. Let's do normalized. So we need like target. So normalized target is gonna be normalized future position minus position. That is the direction that we want to shoot in, essentially. So it's gonna be NT. No, because it's 3D, right? So let's make this. Well, let's just do this. So this is NT. This is the direction. And then, I mean, I kind of enjoy doing math. It's just that sometimes it's like you get frustrated because you get stuck on this, which you kind of know has this very simple solution, but you can't just like get it through, like wrap your mind around it sometimes. God, yeah, game math is so annoying. I remember trying to figure out how to translate between world space and local coordinates when the local space was rotated. Yeah. Man, we might need a whiteboard. Yeah, I'm gonna try this and we'll see. If it doesn't work, then I'm gonna like swap these. And if that doesn't work, then I need to go and to whiteboard mode, maybe. But this is the direction to the future from our current position. And so we need to times that by the speed. And then to have an arc, we just add, you know, going up a little bit. So like 0.3. Because that would, so the kind of the, you know, the XZ, like the 2D kind of speed should be, you know, should be good. Although the gravity will actually come into account here. The projectile might just go like, well, straight down. I guess we don't want gravity for this. We actually don't want gravity. We just want to update the projectiles, I think, to kind of match. Okay. Let's just try it. Future relative is not used. Well, that's a problem. Thank you for telling me. There we go. All right, so there we go. Now we have kind of, well, you know what? Let's try without the, like, let's try without the Y first, so we can like focus on getting this correct first, and then we don't actually want to set a gravity scale there. Okay, so now it should, we should see a projectile being spawned. You do need the tower there. Instead of them just killing the things, they're gonna spawn projectiles instead. 230, make scalar, and blah blah blah. You are the scalar, yes. Scalar 3. Stand it. No. 239. Right. Oh, scalar 2. Sorry. Okay. Wait. Okay, I mean, it's hard to tell what's happening. So first of all, the towers are not supposed to do that. I'm gonna do add 3D body, blah blah blah, tower context, position. Yeah. All right. First try, exactly. Hey, I mean, it looks like it actually works. I mean, it is the correct trajectory. Cool. Hey. That actually was first try. I mean, we had to kind of, you know, change the tower to not fly off into infinity, but the calculation was correct. Oh my god, I can't believe it. Okay. So now, let us... The question is now, let's just have like update project apps. That's probably the simplest way here. Update project files. Enter iterator. Project tile. And we, I guess, make sure that we have the body as well. While. Alright, so let's grab the product tile. Actually, we don't need the product. We need the body. No, actually, we do need both. Well, let's just add grab that there. And product tile. All right. So okay, and then let's get the target. Well, first of all, I want to check if project tile target is valid. If it's not valid, that means that the target has died essentially. So then we continue. Actually, should we? Okay, if this happens, we also destroy the project tile. We should also check if the source is not valid, that means we can't actually get like the damage information. So we probably actually need to like copy whatever we need onto the project file. Instead. So let's do that. So instead of tower context, we actually just need tower. And now tower context is unused. Okay. So we don't need to check if the source is valid because we don't have a source as an entity. We just copy the information. which is actually better because let's say the tower gets buffed after, like you shoot a projectile with a non-buffed version, the tower gets buffed. The current projectiles that are out there should not get the buff because they have like a copy of how the tower was at the time where they were shot. Okay. All right. Anyway, so otherwise, we can move this down here. Otherwise, we get the body. We will try. So the goal here is to check if we're close enough to the target. Or, well, that's not entirely true. I guess, you know what? We could just have a timer. We could have, because we know the time it should take to reach the target. So we could just have a timer on the projectile to like hit at which is when it should hit and when it should like register the hit and get destroyed and deal damage. So that actually, yeah. So now then we don't need to do any. We don't need to do any collision checks or anything like that. We just have a timer that says you should hit at this point. And I guess this comes a little bit hand in hand with the calculation here. So we actually want more things here. Let's get velocity and time or hit. Well, let's just call it hit at. Make it simple. So this is the velocity and hit at is future plus elapsed time. So actually we don't have that. This is the future or time or duration, delay, time. Sure, let's just call it time. So velocity is velocity, time is future. All right. And now instead of doing that, we're gonna get projectile velocity target. So we set the velocity to velocity, and then I'm gonna add this over here now. Okay, cool. And actually down here, we don't need to get the body at all. We don't need the body at all, yeah. We just need the projectile. And we're just gonna check if projectile hit at is less than game elapsed time, then we hit. So then projectile or context is destroyed. Now we deal damage to the target. So projectile target, get enemy health minus equal to random float range. Oh, that's wrong. Wrongly named.
projectile source min damage, projectile source max damage. And later we can have like a more calculating thing for the damage, but okay. There was something in the back of my mind that I needed to fix. So now we should be damaging the thing after a certain time. Oh yeah, also I want to set, yeah. So I'm gonna just write this down. Set direction to velocity. Okay. Actually, how many to-dos do we have? That's the only to-do. Okay. What else is there? Was there? Spawn enemy. Or was it like something in spawn? Oh yeah. So spawn projectile. So actually, yeah. So here we have to do hit at. So that's gonna be velocity time plus elapsed time, because it's gonna be a timestamp in the future based on the current time. Cool. All right. Nice. Okay, and then I have my handy to-do thing. We should code piano someday, just use sine waves. I've actually done that in a programming language called Chuck, which is a really cool language, by the way. It's kind of like Strudel, but I think it's like older, and it doesn't have like a bunch of these nice interface stuff. It's not like a REPL. It's more like just a program language. But you can kind of make, you know, a UI and stuff to control things in it and stuff. And then I tried to kind of replicate how a piano sounds, and then I learned like, okay, a piano actually has like almost like an infinite amount of sine waves, like a real piano, which is kind of crazy. Well, it doesn't actually have infinite, but you know, it's a lot to get that actual piano sound. It's like it's way harder than you think. But essentially, it is just sine waves. I mean, yeah, all sound is just sound waves, so, or sine waves, like added together. But the thing about piano is like it is actually just, it's like it has, well, okay. It's a bunch of sine waves, but it's in like a structured format. Okay, well, anyway, to do, set direction to velocity, yes. So that would be the renderable. I don't know if we actually have that. We don't have rotation here. Well, we have it there. I guess that would be... Actually, that would come from the body. Yeah, okay. So let's put this down here then. I guess we'll do it over here, because otherwise we don't really care, because we're gonna get destroyed anyway. So let's get the body here, context, get body. And we simply want to set
direction, set rotation. Set rotation. Now I need that as well. New rotation, which is a quaternion. Set rotation. No? Okay. I can't set the rotation. God damn it. Okay. I think it's weird because every time you compile, which is basically, in my case, every time I save, because I want the compiler errors in the editor, it's gonna generate new cache, which also affects yeah, so now that doesn't exist. This doesn't exist, but I save, it compiles, and then I will go here, and nothing's over here, so it'll restart my thing. Usually it just works, and now I do load. I guess it's based on hash as well, probably. But yeah, every time I save, it's gonna generate basically like a new copy of things in the zig cache, which eventually grows really fast. Okay, well, anyway. Yo, Phil, I was looking for the past hour. How's your project going? It's going good, actually. I feel like we're doing some good progress here. I have to quit soon, but yeah, I started a bit late today as well. I took a nap before, and I'm basically still tired a little bit. I don't know what's going on. I need to eat something, I think. But yeah, it's going good. Currently working on spawning projectiles from the towers to the enemies. Yeah, power nap. I feel like I have like a lot of sleep to catch up to as a parent. But there's never any time. If it's compiling, it's good. Yeah, exactly. So what are you up to, Phil? Are you're working with the plankton stuff? How's it going with that? I need to find... What am I looking for, actually? I forgot. Rotation, set rotation. I mean, we could do like apply torque, but I just want to set it though. The same as we set velocity, I just want to set rotation. Maybe set target transform? Target transform. Okay, so position and rotation. Okay.
transform is b3 get transform. Make it mutable. Change q set transform to wait. Set no. Oh. Set transform. Position and new rotation. There we go. It's kind of bad that we have to actually get the position to then set the rotation, but whatever. Yes, I'm giving a workshop this afternoon on good practice for data science project. Okay, cool. Data science. Nice. Are you using any visualization for your models to get a better understanding of what's happening? Like looking at maps and I don't know. Tower needs to be that. Target hit at yes. Set rotation needs a thing. So what is that rotation? Rotation is just gonna be can we just take a thing? Shouldn't we be able to just do from angle? Or no? Would this be Y? But then I also want it to rotate up a little bit, depending on... Or could we just take the direction and then have a radius 0? Or the velocity? Uh, 2b3 velocity, and then change u to 0. Oh, hang on, I'm getting a call here. I'm just gonna dip out 1 second here. Be right back.
All right. Okay. Okay, let's see if that works. It's gonna be interesting to see the gravity as well playing a role here. Oh, right, self position. Okay. What happened here? Box assertion is normalized. Oh, right. It's not normalized. Yeah. Okay. Fine. It's not normalized. Wow. Are they really checking if it's normalized? Okay. I guess. Yeah. Okay. I guess we'll normalize it. And now it's no longer the velocity. It's gonna be the direction. Okay. Well, it's not changing the rotation. We are calling this, yeah. When we draw the renderable, are we actually getting the rotation? We are. Right. Okay, so maybe this doesn't work the way I thought it's gonna work. So I'll Google something here. Let's Google direction vector to quaternion. See, there's no information how to rotate around the axis. 2 vectors possible. Okay, I see. Because you need kind of like the right, because there's like an inherent direction of the model as well that we need to also specify, I think.
Take the cross product of your direction vector d up vector u for the side vector s, and then cross river s for new u and is it's well-known math. Okay, dude. What's this condescending attitude? Okay, I can't understand this answer. The cross product of direction vector d and the up vector for the side vector. What is the side vector? None of the way around. Turn into direction vector, but not the other way around. Which makes you think that I'm doing something wrong. But I'm trying to simply display the direction of a directional light using an arrow model. The directional light's direction is a unit vector, but models are rotated using quaternions. So how do I rotate this model to match the direction of the light? Or am I crazy? I can't really do that. Given that the light has no position, but the model does. What? So, take the cross product of your direction vector d and the up vector for the side. What is the side vector? Where did that come from? The side vector. What? Then cross d and s for a new u. Then use d, u, and s as rows or columns, depending on how your calculation rule is set up, as a matrix. Matrix is well-known math. Okay, let's check this one. Conversion matrix to quaternion equation. For a pure rotation, this is where matrix is orthogonal. Why is it so why is this like this? Why is it like this? I feel like it doesn't explain anything. I mean, it has some information here, but I feel like I don't understand. Direction and up vector to matrix. How to create rotation matrix from direction unit vector. My matrix is 3 by 3, column major and right hand. I know it's column. Make rotation direction vector 3 direction up And this gives us the matrix. So here's like the cross thing. X-axis is up direction. Okay, I thought that was Y. I guess it depends. Maybe, I don't know. Okay, so then normalize. Yeah. Okay. Cross and normalize. Normalize fast. Unless you want to normalize slow, you probably want to call normalize fast. Vec3, y-axis, cross from direction to x-axis. I have so bad understanding intuitively about what cross product is doing. So, okay, I'm just gonna do this. Also, how then? This only brings me to part of where to go here. What? Compute between unit vectors. Maybe this is one I want to use. Make from matrix. Maybe this. I don't know, because I don't really know what it's doing. But we have the source code here. So compute, whoops. Compute something, quat. Cross dot compute quaternion between unit vectors. I guess we can try it though. I mean, yeah. Rotation or quat. So could this be like between two positions then? So basically we could do body position and then I guess this would be position plus. No, I don't know actually. But let's just try position plus plus dir. If anyone knows anything about this, I would gladly. Okay, no. Do these need to be normalized as well? Yeah.
What if we just do this? Wait. That actually worked. Except it's like rotated. Wait, does it work or does it? Okay, I need to fix the rotation of the camera. Welcome back, Penguin. So when I press right click, no, that's in control. Maybe. Yeah, here. Why is this doing what it's doing? Okay, let's do this. Let's do like no, hang on. I want, well, actually I could just make a copy here. And then like do that. Actually, we could probably do this. Yeah. And then gonna join that. All right. Actually, we could have that as well. All right, I just want to see what the F's going on there. We got a bunch of nans. Get out of here, Nan. Camera. Sure. We already have a nan over here. Oh, because it's like 0 over 0. I think in this case, we probably want this to be 0. It doesn't actually make sense. 0 or 1. Actually, it makes more sense if this is a scalar, perhaps. We just need a ratio of one of these. And we know that at least one should not be 0, 0. So we are going to grab out because I believe the ratios should be the same. So I guess we could do it like this. If this is 0, we're gonna use 1 over 1, else 0 over 0. Okay, so now this is a scalar instead. Even though it says unknown for some reason. Yeah. dir to the n. There we go. Dird. What's up, Dird? Okay, now it's correct. But it's not correct down here because we need to do scalar to there. All right. And now I don't think we need you anymore. Thank you, log. Debug logging. There we go. Now it works. Cool. So now we can actually rotate to see if these arrows are kind of correct. So they are kind of correct. Nice. I mean, it's slightly off. Is it off? It's moving like left a little bit. Yeah, it's kind of weird. I don't know. But I'm just gonna rotate it 180 degrees in some direction. Well, spawn projectile. No, update projectiles. Actually, we don't need to do this every. Well, actually, we do need if we wanted to go in an arc. But okay, so we have velocity. What we're gonna do is I'm gonna. Do we just negate? I guess we can just negate it. Wait, does normalize keep the sign? Yes. Nice. Except it looks it. Why does it look like sometimes it doesn't actually hit? Yeah, cool. I mean, it started to be something here. We have a fully functional tower with projectiles. Nice. All right. Okay, so now let's also set. I wonder about the kind of the arc, because it should both change the height of the arrow, but also the rotation as well in that direction. So I mean, we could just try to calculate, I guess, try to do like the velocity at the start. Gravity scale is 1. And then we like point it upwards a little bit. So calculate velocity. And now let's point it upwards a little bit. And, you know, properly, we have to probably actually set doesn't look like it's going up at all. Or maybe it goes up from, but I was expecting going up like this, like 0.3. What if we set 1? I mean, I guess it depends. It's just, yeah, okay. I guess it depends on. So now it's going like up like that. Okay, let's set it to like 5. I just want to see how it looks. Yeah, now it's just going like up into the air, but it is correctly kind of moving up, you know, but it's not affected by gravity. It looks like, what if we set like 10 here? I know there is gravity. So are kinetic objects not affected by gravity? Is that what you're telling me? Okay, well then we have to kind of change the velocity every frame. I guess, I mean, since we have the time, we could do like this. We could like, we have this, let's have the start time and the end time, and then we get a ratio from 0 to 1. And then we can kind of calculate what, you know, what arc it should have based on the angle of the starting angle or something like that. So let's have that data in here. So basically, well, we could have like projectile angle. And this would be like 0 means straight ahead. 1 means straight up. So it has to be like from 0 to 1. And let's just do 0.5 because that's going to be like 45 degrees. Okay. So actually then the velocity, the initial velocity is not, doesn't care really about, well, we'll do that. And then when we update, we actually need to now here calculate the velocity based on the time ratio. So we do need, well actually we should have, wait, is it this that I have like created at? No. So let's just have like created at here. Alright. And then you are being elapsed time. Okay, so now we can get that ratio. So we'll get ratio is gonna be projectile so hang on. So we're gonna have like duration is hit at minus created at, and then we're gonna have elapsed is gonna be elapsed time minus created at, and then ratio is elapsed over duration, I believe. All right, so now we have the ratio. And we can say that, so now we kind of need to change the velocity based on this and the original angle. So we need to make a curve, essentially. So let's say we have like t like I know how the curve should look. Yes, but okay. So we have time. We have starting angle. It makes more sense to me to kind of think about this in my head, actually. So at ratio 1, we should be at like an angle, like I guess it would be like 90 degrees, like this, and then we just have to interpolate between, right? Yeah, this doesn't help me at all. I'm leaving you. All right. So basically, we just want to lerp here. And so this would be the The problem is we also need to have this as a velocity. I missed what we're trying to do. Okay, so I'm trying to... Okay, it's easier if I like draw it, I think. So basically, we have a tower here, and then we have an enemy here. And the tower is shooting an arrow. It comes out from the base, so I'm gonna do it like this. So basically, you know, it's a ballistics thing. The tower is shooting an arrow like this. And it's supposed to come down here. So what we have is like, we have like the speed and direction along the ground, you could say. Right now, the arrow is going like this. And that is correct right now. But what I want is to kind of transform it into this. And so what I'm thinking is that the speed along the ground shouldn't really change. It's just a Y speed that's going to change. So it's kind of like different, you know, components. So Y shouldn't affect the speed that we should. It's just going to be for visual effects, essentially. So basically, let's say this goes up at 45 degrees. Then it should come down at, you know, 45 plus, or well, let's just say it's plus 90 degrees. On this thing, it's actually minus, I think. Yeah, but anyway. It should be different by 90, I think. And so then in between, we would lerp this. So angle equals lerp, you know, starting angle, or angle start to, I guess, angle start plus, you know, 90 degrees. And then the ratio is like the time we have taken between. But then also that's not true, because here the velocity, that's not true, because here the angle changes less than over here. So it's actually, we kind of have to calculate like a ballistics here, I think, or whatever it's called, like you know, a gravity, like a, you know, inverse parabola here, or a parabola thing, I think. We can't just lerp. Because that would look weird over here. I guess it would look fine here, but then over here it would look weird. Maybe. Yeah. So you start out at some velocity y, and 0. And then over here, we have velocity y1. And then in between, it's gonna have to be some type of integral, partial integral of this thing. Can I... Oh, can't do infinite. How do I just do like yeah, so basically we start out at this. We're basically gonna do like minus, you know, the step until we go down here. But we have to understand how much we need to do in order to get over here. So we're going up. So do we need more variables? I mean, we have the angle and the distance, and then I guess we need to be at 0 by the time we're at halfway point. So if we so basically we take like the integral of this step, and that has to equal, no wait, that's gonna calculate like the area here. Holy shit. Hello, Jasper, I'm gonna say. Welcome. Thank you for the raid. 71 viewers. Wow. I think that's probably the largest raid I've ever got. Hey, hey. Hey, hey. Thank you. Hello, hello. I'm doing some maths here. I'm working on my first like 3D project, so I'm learning like a bunch of stuff. Okay, I guess I'll show you here. Just I need to do that. So the image is 2D because, well, you can see I'm making a TD. And we have these guys animated and moving around. And then I can add towers that shoot arrows. There we go. And we have like lighting and stuff. Another tower defense game. I mean, yeah, it's not a serious project. It's just for me to learn about 3D graphics programming and yeah, game dev in general. I'm not an experienced game dev, so I'm just learning here, and I just picked this because it was like an easy, you know, kind of easy thing to do. Well, I'm saying that, but then we don't actually. You can see that. Okay, so this is what we've done right now. It's like these projectiles. They are calculating where they should end up to hit the enemy at the correct spot. Easy game to become millionaire like cakes. Yeah, I mean, maybe. Yeah, so that's it. So what I'm trying to do now is basically having the projectiles move in an arc. So that is, yes, it's a Warcraft 3. Like I'm deep in like Warcraft 3. I usually every day I play like a TD on Warcraft 3 right now. Not on stream, but yeah. So yeah, so this is basically a lot like that. Yeah, so I'm trying to make them go in an arc. That's why I'm doing this drawing here. Oops. What the hell? No. Yeah, we don't want to do this. Okay. So basically, is it on Steam wishlist? Exactly. So, like, yeah, I'm trying to make this work here. How was your stream, by the way? What are you doing, Yorps? If you're still around, if you're not deterred yet. It was great. I was implementing SHA512 in assembly for x86. Okay. Interesting. Huh. Is it fast? What made you do that? The idea is to demonstrate how to beat OpenSSL and other libs in performance. Okay, okay. Cool. Well, make a OpenSSL. Is that open source? You could make a pull request, I guess. How to show OpenSSL is bad for production. Okay. Yeah, that's way too deep for me. Are usually like are you more into like web dev stuff, like backend stuff, or like security? I mean, I guess that's more of the security side. Why are they so? Why do you speak Swedish? God eftermiddag. Klockan är 5:30 redan. Hello. Good afternoon. How do you know I'm Swedish? We can't hide a Swedish accent. Okay. Yeah. Cool. All right. I mean, okay, did you utilize any like operating system help for that? Like there's like hardware now that maybe can help. Like the new thing, what's that called? A TPU or whatever it's called. What the hell is that called? Like the thing where you can randomize stuff. What are we doing? We're doing I'm venturing into 3D land. This tower defense game here in 3D. This is my first 3D party, so I'm basically using this as a learning experience to learn 3D. I've learned how to animate these with Raylib, shaders, like lighting stuff here. And I'm also using Box 3D for physics, even though there's basically no physics. It's just used for having a position and velocity and stuff like that. But yeah, it's fast, so you can have a lot of entities. Is this GTA 6? Yeah, I'm working on it right now. It's not hard to guess, but Viking bear. All right. Looks cool. Yeah, I mean, it's just a you know. It's not. I'm not gonna make this as an actual game. I'm just doing a test to kind of get into the weeds of 3D programming. I'm a hardware software engineer and I mostly do low level. Right now I do freelance consulting and cryptography audits. Okay. Nice. Worked on all sorts of things ranging from chip design, supercomputers, hard, soft, cybersecurity. Okay. Wow. Awesome. Yeah, I'm not super big into like security stuff. It is interesting to learn some of the things, like when you get it explained to you. But it's it's not my area. I've been working as a web dev for like 11 years, and yeah, now I want to get into game development. Well, I always wanted to get into web or game development, but I never really, made the jump. You're also working on a game, Hovsäter, but in 2D and in Jai. Okay, what Jai? How do you get access to Jai? Do you have to like sign up or something? Nice to try something new. Game day was great. Yeah, I mean, I've always been interested in games. I've played games all my life, and I've always wanted to make games. I just never had I've always tried to make games, but I never really, deep dove into it and tried it for real. Oh, you reached out. How do you get Jai? What the hell was that? The Jai programming language is currently on invited beta testers. Okay, so you're part of the closely groups or developers working alongside this ecosystem. When you stream and do something interesting, you can ask John for access. Okay. All right, cool. I mean, yeah, I wouldn't say I'm doing that, but yeah. Well, I try to be like a little bit educational about like Zig. People are interested in Zig and they want to learn stuff about that, because I have like done Zig now for a couple of years, So it's a really nice language. Why Zig? Because it's the best language. I mean, come on. Tried to get into Zig, but eventually ended up using Odin for about a year or so. Now I'm porting Odin game to Jai. That's probably easier to do than from Zig to Jai, maybe. I don't know. But I did learn that Jai does have the same kind of comp time stuff that Zig has. I don't know what Odin has in case of that, in terms of that. Well, why Zig? I mean, okay, so I was like looking for a low-level programming language when I wanted to get into game dev. And Zig just stood out to me, and it felt like it had a different feel to it. And I was just interested and tried it out, because I'm also interested in like a lot of different like programming languages. I've been programming for a long time, so I was self-taught in C++. I started like 30 years ago. And since then I've been hooked on programming. So I've been like looking at all kinds of different programming languages. And Zig just stood out as like a new, nice, low-level programming language that was just perfect. And yeah, I started to use it, and then I just got hooked on it. So now I can't really do anything else. Odin has no macros or comp time eval except a conditional when statement. Okay. Jai on the other hand has insane metaprogramming capabilities. Yeah, I saw a video on that actually. I think that it's very similar to Zig, but it does have better like debugging stuff. And also the way what's it called? Like the way you can see like intermediate code, like the compiled code, is really nice. I wish Zig had that, because I don't think you can. I think it does end up somewhere, maybe in somewhere, maybe in some cache, maybe, but it's not like easily accessible, maybe that in the same way that Jai has it. So yeah, that would be really nice. And also to be able to like step through that code. That is like, you can see the final product of the comp time types and all that stuff. So yeah, that would be cool. I think that Zig does have the capability to do that, of course. But yeah, but otherwise it does have like a lot of the same kind of functionality of comp time that Jai has, it seems. I'm also self-taught, picked up programming at 13, never looked back for the last 30 years when freelancing. Oh, nice. Yeah, it's like you get the feeling. I almost like instantly understood that, hey, this is what I'm supposed to do. It's pretty cool. But yeah. I'm looking at this, trying to just absorb it in my brain, see if I can just dream up the solution here. Isn't Zig using LLVM? You should be able to make a plugin that dumps whatever internal data structure you have access to. Yeah, probably. I mean, I'll probably just wait for them to do it. I don't have to. I don't like. It's not like I have to have it right now, but yeah, it does use LLVM. However, they did write their own backend as well, but I'm not sure if they like replaced the whole backend or if they replaced some of the backend. So yeah, so they have like replaced something in the backend to be able to have much faster compilation times, and also incremental compilation, which is experimental right now because there's like compiler bugs, so you can get like miscompilations and stuff like that. So I haven't really enabled it, but it is ongoing. Yeah, and then I just like a lot of the features that it has, like the implicit field access and declaration access. Not implicit field access, but the implicit declaration access is really nice. Yeah, it's actually insane that it doesn't exist in other languages yet. Maybe it will. I don't know. But anyway. They also have their own x64 backend, right? Yeah, I'm not too sure about the details on that, on the backend stuff. I just know that they rewrote something to have faster compilations. So, yeah. It was a really nice upgrade. So, like, the velocity, the speed here is just a straight line, right? And then this is kind of the integral. No, wait, it's a this. It's right. It's this. This is the speed. Well, it's not entirely. I mean, this is like plus something. So it has a starting point, and then it's decreasing every frame, and then we have to kind of know that it should go back to 0 after a certain time. So I guess if we just have this integral. No, wait, not the integral. This is position. Okay, so actually, well, I'm trying to remember the math lessons here. Yeah, velocity never, or is rather like acceleration here. Yeah, because it's gravity, right? So it goes down. Well, this is y. Thank you for the follow, Hovsäter, eller? Isn't that like a town or something? Are you doxing yourself? Oh, it's your last name? But it is a place. Oh, I see. It's like a tiny place. Yeah, it's near where I live. Oops. Shouldn't have said that. But yeah, I mean, yeah, you can maybe you can hear it on my accent. I don't know. But yeah, it's named after the place, family name. Okay. Huh. Wait. No, because this is acceleration, right? And this is position. So that we're missing we're missing speed, right? Okay. Yes. This is acceleration and this is speed. Okay. The speed is actually just a straight line. Yeah. Because that's a parabola. This is the thing. Right. Speed doesn't change. There we go. Or speed changes, but acceleration does change. Okay. Actually, Scratch is not named for that place because the origin from Stockholm. Okay. Yeah, I thought it was weird that it was like a small place called that because I remember hearing about it somehow. I don't remember where or when, but it wouldn't make sense that it would be like a tiny place in like some in the country. So I don't know. I'm from small far west from Stockholm. Okay. All right. Yeah. Hovset. It sounds very. It sounds regal. Because of hov. Or it could mean a hov as in a net. Catching crabs. As we do here on the west coast. Got plenty of shit from friends regarding that. Yeah. Oh man. Okay. Okay, so what do we want? So this is the integral of this plus. No, it starts at 0. But the velocity kind of starts over here. So actually this is like shifted. Actually. It's like shifted like this. Here. No, that's wrong. It's negative. So it's like it's shifted kind of like this. Yeah. Okay. So it starts out with positive and then it like lowers and then it reaches 0, which is the midpoint. Aha! So here is mid. And then this, I mean, this length here should be equal to some length there. And then this is like the end, which is this part here. Okay, I think we're getting somewhere. This basic like calculus stuff here. Man. Okay. What time is it? Okay. I need to go here soon, but and then this doesn't actually, this should be negative, so, but it doesn't matter. I'm gonna just remove this, doesn't matter. Okay, so velocity, we can actually, well, the thing is, we need to kind of find then we have the time. So we know how much time it should take. So if let's say we have this thing and we know the initial velocity, or do we know the initial velocity? Maybe we don't. We just have like an angle. But the angle is kind of based on the velocity, so we could just actually use velocity instead, maybe. No. Yeah, but let's say we have this and it's gonna go down linearly. I guess yeah, and then so this will be like t. So we need to kind of find this line here. No, where it's like t over 2. So t over 2. So velocity. So y. T. Hang on. Y. T over 2 should be equal to 0. So I guess it's just a matter of finding the correct slope here. T over 2, so 0 is... No, well, this is wrong here. Kind of weird notation here. This would be y, where x is t over 2. X is t over 2. Well, how the we could also say like the integral of y from 0 to t over 2 plus the integral. Well, actually, we just need integral from this should be 0. I don't know what that gives me, but I just realized that this area here is equal to this area, and this is positive, this is negative, so they cancel each other out. Man. Wait, and let's say we have, so gravity is constant, right? So yeah, so gravity is constant. That determines the slope. The slope that is like gravity And so all we have to do is kind of shift this up and down depending on t to kind of start at the correct place and to have t be, you know, in the middle here, or like, because if we start over here, then the midpoint is way off and we end up down here, so they are not equal here, right? So we have to find the place where this function is 0 when x is t over 2. So let's say, you know, y is, you know, negative x or something, then and then plus some initial thing, which I'm gonna say is, this is the variable really. I'm just gonna say z here. And so when y is equal to 0, that is where x is equal to t over 2. Okay. So then when x is t over 2, this should be 0. So negative t over 2 plus some mystery value should equal to 0 in this case. And if we change the formula here, we have to kind of work our way through. But well, let's say we have a multiplier ax plus, then this would be x equals t over 2 yeah, that's still the case. But how does that translate down here? That's gonna be negative a t over 2. So at. So let's say this, you know, if you have a different slope, right, and it's acceleration, so it matches here. So at over 2 plus z is equal to 0. And we know what t is. We know what t is. T is a constant here. A is also known. Yes, that's also constant. These are constants, so these can be calculated. And then we could just move z over here. Z is equal to negative a t over 2. No, it's not. It's negative z, right? We have to think about the polarity here, and then, you know, we can just reverse. So z is actually equal to a t over 2. There we go. And that's the starting point that we need to have. And so, yeah. So then essentially here we could replace this formula by saying y is equal to negative ax plus a t over 2. If this checks out. I don't know if this actually works, but I think that's the velocity function. Where x is a ratio of t here. No, it's not. Well, yeah. Well, we'll figure it out. Okay. Because the thing is, we have a ratio of 0 to 1 with t. We don't have like an actual unit there. We have 0 to 1. I guess it doesn't matter. So let's say x is, as t is from 0 to 1. If it's 0, that means it takes 0 time to reach 0. It's over here. If it's like 2, it means we have like this is 1 and this is 2. So then at 1 we should reach, well, at 1 this would be, well, sorry, yeah, at 1 this would be like a plus, no, negative a plus a, because t is 2, so t over, so that would be just, this would just be a, negative a plus a, so that's 0. So that checks out. Okay. So then the velocity of, it's actually like velocity y we're talking about. Is going to be whatever we said here, negative ax plus at over 2. So where x is ratio, a is like gravity, and then we have to calculate this one, at over 2, where t is actually 1 in this case, so it's just a over 2. Okay, so it's like gravity over 2. So it's like gravity x, negative gravity x plus gravity over 2. So I guess we'll define gravity here. I don't know what to pick, so I'll just pick a number here. And then this is going to be, I have to go back, negative ax, so negative gravity times ratio plus gravity over 2. And I'll make this into a float, and this, so we don't get like truncation happening. Okay. Nice. So now we want to set velocity. Let's grab out the old velocity. So velocity y, or y is equal to that, and it is the new velocity is v, and then we grab it out again, even though we already have it. We should just be able to use v here. And oh, you're actually F64 because ratio is F64. So let's do F32 there, and then we have to do a float cast. All right. Cool. So yeah, I mean, this is kind of, now the question is, what is the initial then? It's gonna, I mean, the initial is gonna go up. Yeah. Because technically, depending on the speed, you could, like, you know, throw straight and it will reach the target, you know, going down. But that's not how we kind of calculate it. Because then the velocity should start at 0 and then just go down until we have time. So it could go like this, you know. I guess until, like, position then is 0. So then you have to take position into account. This is only like velocity. It goes up and then go down. Hopefully, we'll see. If this is correct. Oh! Wait, is it actually working? It is actually working. Holy crap. I mean, it looks like shit because it's not actually, like, going all the way. But yeah. Cool. Also, I'm not sure why, like, the initial one. But yeah, awesome. We got, you know, arrows in an arc. It was nice seeing you reason through that. Yeah, hopefully that was, you could follow my thoughts there. I mean, the diagram, I usually don't do diagrams like this. But this one, I just had to kind of work my way through. And it was so slow at the beginning. To actually try to find a solution here. And also I need to kind of, if I want to have this, let's say I want to shoot from the top here instead, we have to kind of modify this because then it's going to be something like this instead. So we actually have a different curve here. I have a remarkable paper pure I use a lot for all the mathy stuff. Super helpful. Okay, cool. Remarkable paper pure. Is the, I mean, is it a software or what is it? An e-ink tablet. Oh. Interesting. That is interesting. I've never actually seen like an e-ink thing in my life. It's like writing on paper, except I can work much faster. Huh. Okay. Oh, hang on a second, getting a call. Right, that's a good point to end it here. So nice. You don't get Suddigum's load now. I just use my computer for everything. I don't remember last time I actually wrote something on a paper. All right, but yeah, that's gonna be it for this time. It kind of looks weird. It's like the rotation is not correct. I don't know. Maybe I'm just paranoid. Okay, well, anyway, that's gonna be it for this time. So yeah, thank you very much for watching, and hope you have a nice day, and I'll see you later. And now that we have a couple of people here, we can raid. read. Do I have to refresh as well? I'm just gonna refresh as well. Yeah, thanks. Thanks for following. And for the company here. What's this? Working on game 2. Godot. Oh, here we go. Particle physics. Hello, Vincent. All right. See you later. Let's go.